In this video, we're going to look at section 2.1, activity 3, number 2. And we're going to start off with a couple definitions here, an independent variable and a dependent variable. So the independent variable is the quantity that's manipulated in an experiment. The independent variable is the variable that's placed on the horizontal axis when you're making a scatter plot. The dependent variable is the quantity that depends on how the independent variable is manipulated, and the dependent variable is placed on the vertical axis in a scatter plot. The designation of the independent and dependent variables can depend on context. So what we want to do now is look at some different scenarios and see if we can identify the independent and the dependent variable. So let's look at this again one more time. So the independent variable is the quantity that's manipulated. The dependent variable depends on how the independent variable is manipulated. So we're going to go look at the previous problem, which was in a separate video, but you should have watched that first, or at least gone over this problem, which was the problem where we pulled back a car and then see how far that car traveled. So one of the variables is the distance that the car is pulled back, and another variable is the distance traveled. Well, we could look at our graph and how it was plotted out and figure out which one is independent and dependent, because we read that the independent variable is placed on the horizontal axis. So the independent variable is the distance pulled back. The dependent variable is placed on the vertical axis, so the dependent variable is the distance traveled. Remember, the word variable means it can change, it can vary. So we're varying the distance that it pulls back, and that's varying the distance that is traveled. Both of these values can change. Now, the distance that the car travels depends on how far the car is pulled back. So there are some situations with two variables where making one of them the independent variable is the obvious choice. We're going to see some situations where you could really do it either way, but there are many, many, many circumstances where one variable is the obvious choice to be the independent variable. This is what's changing. This is what's being manipulated, right? We're changing or manipulating how far we pull the car back, and the distance that it travels depends on how far we pull the car back. All right, so let's go over here and write this down for that particular problem. So the independent variable is the distance the car is pulled back. And then we're going to write the dependent, let's make this a capital, we'll make it like a complete sentence. The dependent variable is the distance traveled. Okay. Now, what I want you guys to do, actually we're going to go through this 3A together. And what we want to do is identify the independent and dependent variables in each scenario. So 3A says the height from which a ball is dropped and the time it takes the ball to hit the ground. My piece of advice is the first thing to do is to identify the two different variables. So the two different variables are the height which a ball is dropped and the time it takes the ball to hit the ground. Okay, so we want to think which one of these depends on the other one, or which one of these could we manipulate? Does the height that you drop it depend on the time it takes the ball to hit the ground, or does the time it takes the ball to hit the ground depend on the height which it's dropped? If you could manipulate one of these two things and change it, you would probably manipulate the height at which you drop the ball, and then the time would depend on that. Okay, so in this case, the height is the independent variable. Independent. And the time is the dependent variable. Now, it doesn't tell us in this scenario how height or time is measured, right? Height could be in feet or inches or yards. Time could be in seconds or minutes. That's okay, that's fine. All right, why don't you guys pause the video and see if you can do B. Take a guess. Well, first let's identify the two variables. Let's use different colors here. So the amount of material to be ordered for the costumes of a play. So the amount of material is one of the variables. And the number of performers in the play. So the number of performers is your other variable. Number of performers. Okay, which one is independent? Which one is dependent? Does the amount of material you order depend on the number of performers in the play? Or does the number of performers in the play depend on the amount of material that you buy? Right? Probably not, right? The amount of material depends on the number of performers in the play. So the amount of the material is dependent, and the number of performers is independent. So if we were going to graph this, which we're not going to graph these, but if we were, then we would want to put the amount of material, I'll just color code it, we would want to put the amount of material on the vertical axis, and we would want to put the number of performers on the horizontal axis. Okay? All right, number 4 is a little creative problem for you, so I'm going to leave that to you to do. Number 5, the table to the right shows weight and fuel efficiency for 10 different cars. Identify the independent and dependent variables. So we have cars here. This is how much they weigh in kilograms, and this is how many miles per gallon that they get. So we have kilograms and miles per gallon. Go ahead and pause the video and see if you can determine which is the independent and dependent variable. So again, we can ask ourselves, does the weight depend on the fuel efficiency, or does the fuel efficiency depend on the weight? And I think we're going to say that the fuel efficiency depends on the weight. Okay, so our independent variable is going to be the weight of the car in kilograms. And our dependent variable is going to be the fuel efficiency in miles per gallon. I don't think efficiency is going to fit here. Okay, in miles per gallon. All right, so the next thing we're asked to do is to create a scatter plot of this data using Desmos, and be sure to label each axis. So since the weight is the independent variable, remember that's going to go on the horizontal axis. So here we're going to have our kilograms, our weight in kilograms. So this is going to be, this table is written how we want to do it. These are our x1 values in Desmos. And then the miles per gallon over here, I don't need to put this in parentheses, is going to be your y1 in Desmos. Okay, so go ahead and pause the video, go over to Desmos and do that. We learned how to use Desmos in one of the previous videos. So this is what your scatter plot should look like. Pretty close to this. Now you may have a slightly different scale on your x and y axis, right? If you're like zoomed out or zoomed in, it might look slightly different, but one of the things that you really need to pay attention to on Desmos is your scale. Some of you probably started this off and thought, oh, I'm doing something wrong, I can't see the points. But you really need to pay attention to your x values, how high these are, well, compared to your y values. So you need to make sure that your x values are covering the x values in your table, getting at least that big. Remember a little tip to hold down the shift. Notice my mouse is changing, and then I can easily manipulate this value here. You can also hit the little wrench and change your values here. And you can also put in your labels there as well, which is nice. Okay, let's go back and see what kind of questions we need to answer. As weight increases, what tends to happen to fuel efficiency? Let's take a look. So as the x value is increasing, or the horizontal, the independent variable, let's call it, is increasing, what's happening to the fuel efficiency? It looks like it's decreasing, right? We can see that pretty easily from these points as compared to looking at this table that was a little bit harder to see, actually probably a lot harder to see. So let's write this down. So we can say it decreases. All right, next question. Describe what the data point 1737, 21 on the scatter plot says about weight and fuel efficiency. Well, let's go ahead and take a look at that point, even though we don't really have to answer this question. Let's see, 1737. Remember, you can click on these points to find, there it is. There's the 1737. This data point here represents a specific car. And that car, this point is telling us information about that car. Okay, what information is it telling you about the car? It weighs 1,737 kilograms and it gets 21 miles per gallon. That's what it's telling you. Okay, so we know it weighs. I'm trying to write in complete sentences to model good mathematics here. So it decreases. I was trying to decide, is that a complete sentence? I think it is. It weighs 1,737 kilograms and gets 21 miles per gallon. E, what is the fuel efficiency of the lightest car in the list? Take a look at that. Pause the video, go find it, write it down, and then we'll talk about it. All right, well, we could get that from the table or the graph. We could find the lightest car in the list here. This looks like, okay, right here, this guy J is the lightest car, so 29 miles per gallon. And how about the heaviest car? So the lightest car is 29 miles per gallon. And the heaviest car, let's see, looking at this list, 19, oh, this one's heavier, 2384, so that's 16 miles per gallon. And the heaviest car is 16 miles per gallon. I'm not modeling my good behavior of writing out complete sentences, but you could do it. Now, looking at the graph might have been an easier way to do that. So the lightest car we could find as the rightmost point. Let's get rid of this one. Right, there's the lightest car, there's the heaviest car. So when you're looking at the graph, it's a lot easier to find the lightest car and the heaviest car by finding the rightmost point and the leftmost point. F, use your scatter plot to estimate the fuel efficiency of a car weighing 3,000 kilograms. So in order to do that, we're going to need to take a look at our graph, and we're going to have to try to find the line or pattern that we think this graph is following. It does look like a line, kind of. It may be maybe making a little U-turn here. This is sort of up for you to decide. Okay, so there's not one exact right answer for this estimation, but you do want to make sure that your graph is such that you can see 3,000 on your graph. Okay, so if you don't have that on your Desmos graph, go change it so you do. Okay, so then what you want to do is you want to visualize a line or whatever you think is happening. I'm going to go ahead and do something like that. I mean, it could be, you know, which one of these is it? I don't know. Okay, it's somewhere around in there. And then I'm going to put a vertical line on 3,000. Well, I can kind of see where 3,000 is right there. Maybe I don't need this vertical line. Let's put it in there. I wonder if this line's going to... It's short enough. I bet I could just draw it. Let's use this for our horizontal line over to 3,000. And I'll draw the vertical one. Okay, so let's draw this vertical line here to 3,000. Oopsie. Let's try that again. Technology, right? So since we want to know how much, let's get this out of the way, what the fuel efficiency is for a car that weighs 3,000 kilograms, we need to draw a vertical line straight up from 3,000 kilograms, which is this line right here, right? The line's already here. And see where that line intersects our predicted line, this green line. And of course, this green line is a little bit up for consideration, right? So if I put my green line there, then I'm going to draw my horizontal line from the point of intersection of 3000 and this green line, and then I'm going to go straight across here and see what number I get, which looks like these are increments of 2. The way my graph is written out, you guys might have a little different scale here, so you got to figure out your scale. So my scale looks like a little less than 4 miles per gallon. That's pretty sad, isn't it? If I would have moved this line, maybe I thought, oh, I think maybe this data is more following, say, a line like that, which I could predict, okay? These points are scatter plots, not in a perfect line by any means. Then I would extend my 3000 vertical line up until it intersects the green line, and I'd move my horizontal line up to that point of intersection, and that prediction would be a little less than 8 miles per gallon. Okay, so there's no one perfect answer here. We're just estimating. But the idea is trying to predict what would happen with a piece of data that we don't quite have. All right. So hopefully that was helpful for you guys in learning how to use scatter plots and where your independent and your dependent variable are. So again, your independent variable is going to be down here. And your dependent variable is going to be on your vertical axis.